Okay, so now let's work on that question for the next question here. We need to work on this. Let's continue working on the question paper. Let's see what we can do from this question 4. So now, looking at question 4, this is momentum, and I'm not sure if we're going to have enough space for doing the calculations here, but I'll try. So a trolley A of mass 1.5 kg is at rest on a frictionless horizontal surface. So that is the first statement that I'm given, and I see the word rest. So this tells me that since it's at rest, the V initial of A is 0 meters per second. I hope you understand that part. So trolley A will have the V initial of 0 meters per second. Okay, so they say that a second trolley B of mass 2 kg traveling horizontally at a constant speed collide with a trolley A. So they're going to collide, then they stick together and move at a constant velocity. Guys, constant speed and constant velocity, it's not the same. We're going to discuss that as we move. If you need to understand this, then based on the questions, yeah, then we'll talk about it. To the right, so covering a distance of, so they move to the right after collision, and the distance is 0.8 meters in 2 seconds. So now what I'm going to do, I'm just gonna put this information here and say after collision they move delta. Since this is horizontal, we're going to call this delta x. They move 0.8 meter, and at a time of what, 2 seconds. Okay, so now ignore all frictional and rotational effects. First question, state the principal conservation of linear momentum. So the principal conservation of linear momentum, it says that for 4.1, it says that the total linear momentum in an isolated system in an isolated system is conserved. Remember what we talked about on the multiple choice questions, né? So that's the total linear of momentum. So is conserved, right? Or you can say remains the same, or it remains constant. You can say that. So that's the principle of conservation of linear momentum. And then 4.2, they want you to calculate the speed v which the trolley B moves before the collision. So you know what I'm going to do. When I look, I think we can have enough space to work this 4.2 maybe here on top. Maybe we can just put the 4.2 on top, or we can just move it down here. Né? So they said that they want us to find the speed which trolley B moves before the collision. First thing first, they said they want us to state linear momentum. You know what? For the fact that they said, remember I said in physics, whatever that they want to state, just know that the following questions will be based on that. They say define the term free fall, and the question was based on free fall. They said define Newton's first law, and most of the questions were based on Newton's first law. So this tells me that if they said state the principle of conservation of linear momentum in width, I can just write that down and see how can that help me to find the speed v. I think you guys are learning how I attack these questions. Né? So this will be my 4.2. So on my 4.2, I'm going to say the change uh, of momentum before, it's equals to the change of momentum after. So now, why are we using this? Let's quickly work on that, because remember there's a collision. Let's say before, we're going to say the mass 1, we need to multiply the mass 1 with the v1 initial, the velocity of the mass of the first object. Then we need to add this with the second mass multiplied by the velocity of the second object. And this, we're going to equate it to what? We're going to equate this to m1 v1 final. m1 v1 final, please just give me a second, this will make sense now. M1 v final, then we need to add this with the second mass multiplied by the velocity of the second object, which is b, and then this will be f, the final velocity. Okay, so you know what I'm going to do. Let me substitute what I have on this equation, because I think it's easy if we just substitute. So the mass 1, which is, we're going to say my mass 1 is trolley B, and I'm going to use my mass 2 as trolley A. Is this making sense? Yes, we can do that. So this will be m1 on my substitution, and this will be my m2. So now my m1 is 2, my m2 is 1.5. Let's quickly substitute that. m1 we said is 2 into the initial velocity of that trolley B, which is v. They want us to calculate the speed v, so I'm going to substitute that as v. So I'm just going to leave this as what? As v, because this is what I'm trying to calculate, plus my mass 2, we set mass 2 it's 1.5, which needs to be calculated by the initial velocity of trolley A. Remember, trolley A is the second mass, which is 1.5, and the initial of 0. Let's quickly substitute that, and this is 0. Then this is equal to, because now I don't want to confuse myself, I know that there's something missing, but now I just have to verify by substituting everything that I have on this equation. Then the equation will tell you what you miss and what you need to calculate. So now this 2, this is after collision, the object move together. So since the object move together, they will move with the same velocity. So we can write this equation as the mass 1 plus the mass 2, then put these two guys inside the bracket and say this is my v final. So they will move with the same velocity. So I can add the two masses, which is 2, we add that with 1.5, then let's close something here, v what? V final, the velocity that these two objects will move together with. So this will be my vf. So now look at this. Look at this. What is going on here? We are looking for this v, and the final velocity, it's missing. Let's go and try to find a way how we can calculate the final velocity after momentum and come back and substitute it here. I know that if I go back to the statement, we'll get something that can help us to solve this problem that we currently have, because we have two unknown variables. There's nothing we can do from that. Let's go back to the statement. So the statement said that after collision, because that's the velocity that we are interested in, the velocity that these two objects moved with. So after collision, they traveled a distance of 0.8 in 2 meters second, and this is the data that I have. So now I know that I can use what? The equation of motions from the vertical projectile motion, because this makes sense looking at what I have. I know that when you are in an exam, it's not easy for you to just think about it and say, you know what, this will be equation of motion. I can use the equation of motion to find the missing velocity. You know what you need to do? Think about it like this. Think about it like this. I'm just going to teach you something. Now, look at this. Delta x. Oh, delta x. I know that in work, energy, and power, when I have delta x, it's when I calculate the work done. But now, I can't use the work done to find the velocity. So where can I have delta x? Then you go back to your formula sheet. Now, you consult your formula sheet. Remember, we just assumed that you are in an exam and you don't know what to do. And now I'm training you how to master these questions. Now, then you'll see. It's a ding, ding, ding. So now look at this. I'm going to say, I'll go through my formula sheet. Okay, these are the constant values. Then when I go through my formula sheet, I'm looking for delta x. I'm going to check where I have delta x in my work, energy, and power. So there's no delta x. It's only here when we calculate what? The delta x, it's only here when we calculate the work in the work done. So that won't help me because it doesn't have a velocity. I need to have velocity and delta x on one equation. Then if I have that, that can assist me. So now I'll really appreciate to get delta x and the velocity. So this one won't work. Let's see. Okay, look at this. This one is the v initial. We know that no matter what, that v initial can be our v final, but we can first find that v initial on that equation. So the only formula that can work, the only formula that can teach us, that can help us, it's one of these two, but I'm just going to choose the first one. So let's go back and write down that formula and work on it. I hope you guys understand how we are bringing that formula to what we are currently working on. Please don't be confused. You know? So now we are saying that we're going to use the equation of vertical projectile motion that says delta x it's equals to v initial then delta t plus 1 over 2a the delta t squared. Right, so now what I'm going to do, I'm just going to rearrange my formula and say delta x is equal to, remember the information that we're going to substitute, it's after collision. It's after collision, and after collision I need to have the v final. So I can, instead of using this velocity v initial, I know that I can substitute that as v final, but it's fine. Let's just work on this the way it is now. So let's do the substitution. When we substitute, we're going to say delta x, the distance traveled after collision, it's 0.8. So I'm just going to substitute this as 0.8, equate this to v initial, and they said this will be done in 2 minutes, so 2 seconds. So this will be 2 plus, now if I don't know guys, because look at this, please pay attention on this one. Now I think we are having so much fun. Look at this, because when I see a lot of tricks, this is where I enjoy them. The problem, I have this as 1 over 2a delta t squared. It's not squared, is this squared? Did we write the squared here? No, we don't have the squared, so it should be delta t squared. Look at this. When I look at this problem, I know that the time is going to be that 2 seconds, because they said this will be done in what? This will be done in 2 seconds. So now, what about this a? Can we substitute a as 9.8? No, we can't do that. Why? Because delta x itself is telling you that we are working with what? We are working with objects that are horizontal to the surface. We only substitute a as 9.8 if the object is moving vertically. This is not moving vertically, but now you're going to be confused. How am I going to substitute to find a? Because now I'll have two unknown. I'll have v initial and a. So look at the question. Remember, we just underlined that they stick together and move at a constant velocity. Constant velocity tells you that the acceleration is 0 meters per second. The acceleration, it will be 0 because this moves at a constant velocity. Right, so this tells us that we're going to substitute that a as 0, which will make everything there to be 0. So this will be 2 squared. This will make everything to be 0. I'll have 0.8 equated to v initial multiplied by 2. Divide both sides by 2, divide both sides by 2. Therefore, I have my v initial to be equals to, when I say 0.8 divided by 2, this gives me 0.4 meters per second. This v initial is the velocity after collision. This is the velocity that the two objects will move together with. So I can conclude and say, therefore my v final is equals to 0.4 meters per second. So now that we have the v final, we can just substitute everything now. So this will be 2v plus this is 0, then equate the 2v to 2 plus 1.5. I think that gives us 3.5. So this will be 3.5 that we need to multiply with the v final, right, of 0.4. So now I think you know what you need to do just to be on the safe side. On this step, after finding this guy, come back and substitute it here because there might be a mark. Remember, there might be a mark for the formula, and they'll give you a mark for the correct substitution. So come back and substitute it here before you do that step. So now I think it's easy for us to find v. We can just divide this side by 2, divide this side by 2. So v is equals to 3.5 times 0.4, and we divide this by 2. This gives us 0.7 meters per second. So this is my velocity of trolley B before the collision. Right, so now they are asking that, is the collision elastic and inelastic collision? So ladies and gents, if an object collides with another object, and then after the collision they move together. So after the collision, if after the collision they move together, it's inelastic. So the correct answer here is inelastic because they move together. For the fact that they stick together, we're going to say this is inelastic. But if they don't stick together, it's going to be elastic. So the correct answer is this one. Okay. During another, because they don't want you to give a reason, just choose the correct one. Please don't do guesswork now. During another collision, listen, during another collision, trolley B exert what? A greater force on trolley A. And the change in momentum of trolley A is the same as before. How is the time for the collision affected? How is the time for the collision accepted? Choose from increase, decrease, remain the same, and write down a relevant equation that supports my answer. Obvious, I'm going to use an equation first before I can even know if which one is the correct one to choose. I'll first write an equation. That's what I'm going to do. So during another collision, trolley B exert greater force. Which force are they talking about? The F net. Right? And the change in momentum of trolley B is the same as before. The change in momentum. So I also have the change in momentum, and what is the change? Is delta P. Then is the same. How is the time? This is delta T. So I'm going to find a way on trying to understand how is F net, delta P, and delta T in one equation. Go to your formula sheet. Guys, can you see what I'm doing here? This is nothing but the best. Look at this. What I'm giving you guys, the way I'm teaching you how to answer questions. This is the best because look at this. 4.4. During another collision, trolley B exert what? A greater force. We underline a greater force. We know that they are referring to F net on trolley A. And the change in momentum, then I write delta P, is the same as before. How is the time? Delta T. So I'm going to look for F net, delta T, delta P that are on one equation. Let's go back. I know that you guys already know which one it is, but I just want to make sure that we are on the same side. So when I look at this has to do with change in momentum. Should we go back up or where is that? Okay, so look at this. F net delta P change in P. So this is the formula that we can look at. Let's go back and write that formula down, then we'll see what we can get from that formula and try to understand what will be the correct answer there. Okay, let's look at what we have here. I'm going to say I have my F net. Okay, where can we write this? F net, then this is F net times delta T. It's equals to the change in P, right? It's equals to the change in P. Therefore, let's make F net subject of the formula. You can divide both sides by what? You can divide both sides by delta T. So F net is equal to change in P all over the delta T. So the only thing I'm interested in, they said that how is the time for the collision affected? We are exerting what? A greater force. But now the change in momentum of A is the same. So I'm going to remove this statement from my equation. I'm not gonna focus on this because there's nothing changing on the momentum. So this guy here, this is something that you don't have to focus on your formula. I hope you guys understand what I'm saying there. So the only thing that you are interested in is to understand what happens if the F net increase, what happens to the time. Let's go into our formula. So I'm just gonna avoid the delta P. So F net, we know that is directly proportional to 1 over delta T. So inversely proportional, I'm sorry. So I have F net to be inversely proportional to the time. So this tells me that for the fact that F net is 1 over delta T, what happens if the F net increase? If the force increase, this guy decreases. So this tells you that, remember from Newton's law, if we have, let's not bring the Newton's law. So F net, it will be inversely proportional to delta P. So if the force increase, the time will decrease. So we can see that F net is directly proportional to delta P. If the F net increase, the change in momentum increase. And if the F net increase, the change in time decreases. So the correct answer there is decrease. Then when they say write down the relevant equation that support your answer, we can give them and say that, guys, take this and give us that 1 mark. You can say F net is inversely proportional to 1 over delta P. Please use the inversely proportional sign. And that's it for this question. I think we spent a lot of time on this question and we were just supposed to just move, but it's fine. Let's look at question 5. The water is drawn from a water source that is 12.5 meters below the ground by an electric pump. Okay, so they say it is drawn below and the water is 12.5 meters down. Okay, so now the water is lifted vertically upward at a constant speed as shown in the simplified diagram below. So the water will move up and then it will go in that direction on the ground. and this is our electric pump that we are using to take the water down. Ne? So the pump lifts the water upward at a rate of 2.5 kg per second. Ignore all the frictional. What is this weight? Physics little like gamma, man. Yes. Define the term non-conservation force. What is a conservation force and non-conservation force? When we talk about a non-conservation force, we are talking about a force for which the work done, a force, I won't forget this one, a force for which, we can say this is a force for which we can say the work done in a moving object. So remember, we need to say in a moving object. So the work done in a moving object between 2 points. Depend on the path taken. So it depends on the path taken. That's the non-consecutive force. But please try to consult your exam guideline. Ask your exam guideline, hey buddy, how do you want me to define this? Next. So 5.2, they say draw a label free body diagram showing all the forces acting on a fixed mass of water as it moves from the source to the ground. So the mass of water. So let's say this point somewhere here, I have the mass, let's call this MW, the mass of water. Because even water, guys, has mass, né? Let's call this MW. So if the mass is moving and is this on this point, so what you need to ask yourself, how did the water, what happened? How did the water move from this point to that point, to that point, to that point? Because there is a force that is applied, and what is that force? Is the force of the pump. So let's call this F pump. Then, now, we know that the water, since it has mass, is going to have weight that is acting down. So this will be my FG. So there, to draw the free body diagram, this is 2 marks. This tells us that we need to have 2 forces. So to draw the free body diagram, you already have it, and that's it. So this will be my 5.2. We are saying that the free body diagram will be the force of the pump and the weight of the water, Fg. So now, let's continue answering this question. The pump lifts 200 kg of water from the source to the ground at a constant speed. Calculate the work done by the pump. So when they say the work done by the pump, so now remember, I told you guys, please, you see, if you can listen to me, listen to polite, guys, listen to polite, and I will tell you this politely. Whatever that you do, if you don't know how to answer the question, just try from starting from what is the question saying, the work done by the pump. So now I said that, listen to polite, I said that each and every question, they will start by asking you to define something. Most of the calculation will be based on that definition, non-consecutive force. So this is NC, the work done by non-consecutive force. So on your work, energy, and power, go and look for the formula that has NC. Then you will definitely have an idea on what you need to do. you'll definitely have an idea on what you need to do. But now, what we're going to do is that when I look through this problem, they said that let's go and check what is the formula for non-consecutive force. I'm going to look for the formula that has NC then. Everybody, where are you? We are looking for you. This is the one. The work done by NC is the change in EK plus the change in EP. Let's quickly go back and write that formula down. If you listen to polite, and then you're going to collect your marks politely without like too much stress, no stress. Ne? So the work done by NC, this is equals to the change in, that was the change in EK. We add the change in what? The change in EP, potential energy. But now I think this is going to be more complicated, and I'll try to make it more easy because, hey, this 3 marks, I need that 3 marks. Right? So you know what I'm going to do? I know that the work done by a non-consecutive force. What is a non-consecutive force here? There's only the non-consecutive force will be the work, the force applied by the pump. So we need to find the work. So this will be the work done by a pump. So this will be the work done by P for pump. This is equals to. So now remember the change in EK, the formula for change in EK, it's, I'm just going to write this down. EK, we know that EK is equals to 1 over 2 mv squared. Do we have the velocity? Let's go back to the statement because we don't have the velocity. They said this moves at a constant speed, so the velocity of this is what? Because of the weight constant, the velocity is 0 meters per second. So this gives us the right to say everything on EK, it will be 0. So I'm just gonna say this is 0 plus the formula for this is mgh. So to find the work done by P, we can say this is mgh, and the mass of the water is given as what? The mass of the water is given as 200, and then what is G? Is just 9.8, and the height, the water that will travel is 12.5. This is my height, so I'm just going to write the 12.5 there. So this will be 12.5. So when you punch this on the calculator, you should find the work done by the pump. So let's quickly put that on the calculator. 24,500 joules. That is the work done by the pump. But guys, when I look at this, let's look at this formula here. The work done. Let's say you don't understand that you are in an exam and you don't understand that the work done by a non-consecutive force is NC, then you consider using this formula. The work done by which force is doing the work? Is the pump, because it's moving the water. I'm trying to think about this question. So is force, the work is equals to F delta X, the cos of theta. Let's go and see if we use that formula, are we going to get the same answer? Because now someone might not prefer to use the work done by a non-consecutive force. So let's say someone says the formula that I will go with is the work done by what? What did we call this? The work done by the pump. So this is F pump. Ne? So we said we'll call it the F pump because it's the one that is doing the work, is the one that is moving water from deep down all up to the ground. And then we're going to say this is F of the pump. It equals to this will be the force of that pump. So let's write this because so that we can get space. Né? Okay, so now if we look at this, let's just clean here so that we can make the space now. So we are saying that we can use the formula, the work done by the pump is equal to the force of that, let's call it FP, the force of the pump, delta X, the cos of theta. So I think the challenge here might be calculating FP. Let's go back to our free body diagram, because each and every time I need to calculate a force, I check my free body diagram. So we know that these are vertical forces. So this tells us that we can equate this and say F net it's equals to 0 because these are vertical forces. So we take a force that is going up, which is the FP, I'm going to call it F pump. We minus the force that is going down and we equate this to 0. So the aim is to find the force that is done by the force of the pump. So this is equals to the weight. So FP is just mg. What is the mass of the water? It's given as 200 multiplied by 9.8. So we just have to punch this to find the force of P. We just have to punch that on the calculator. Okay, so now when I put this on the calculator, I get the force to be 1960. So 1960 newtons. So that is the force done by the pump. So I think if I go back here, I can substitute the force done by that pump, which is 1960. I'm going to multiply that by delta X, the distance traveled by the water, which is given as 12.5. So I'm just going to put it there and say this is 12.5. Okay, I'm very sorry guys, sinuses there and there. Okay, so I'm saying that I just want the work done by FP, the pump, it's equal to the force, it's 1960, delta X is 12.5, the cos of, let's go see what is the angle there. Remember, the force is this one, and it is in the same direction as the displacement. So since they are parallel, the angle is 0. Remember, when you calculate the work done, you check the force and the displacement. If they are in the same direction, the angle is going to be 0. So this will be the cos of 0, and the cos of 0 is just 1. You just have to punch this on the calculator, and I believe that this should give you the same answer that we got here as 24,500 joules. So let's quickly verify that. And ladies and gents, when I put this on the calculator, this is 1960, 12.5 times cos 0. This gives me the same answer. And that's it for this problem. We're not going to do, okay, that's it. So now on 5.3.2, they say this was 5.3.1. That was 3 marks. Next, the speed, calculated the speed at which the water is lifted. They want us to find the speed, the constant speed. I think this is, if you go back to grade 10, and when you were doing waves, vector, in grade 10, we said that the V in grade 10, why are they asking something like this? How can you remember that V, the constant speed, this is 5.3.2. The constant speed is equal to distance over time, right? Distance over time, that's the formula that we need to use. So now the distance, we know that is 12.5, but what about the time that it will take to for the water to travel that 12.5? We need to find that. So to find the speed, we're going to say this is 12.5 and this is divided by, we're going to divide that guy by delta t. So now how are we going to find the time? Guys, remember that this is water going up. This is water that is going up, and looking at the rate that we are given here. You know, when I was still in school, when I do calculations, this is what I do now. I'll be calculating, then I go back to the statement, I check, Rayman, why are they giving me this? Because I haven't used that. So this tells me that maybe this calculation has to do with that. So that's how I used to find my way around. So now, looking at this, what is 2.5 kg per second? Guys, I know that most of the time when you're doing the caps, you normally don't get this kind of SI unit. But now, because the question paper is a sub exam, remember this is a sub exam, anything can happen on this question paper. That's the issue with the question paper, anything can happen. So what I need you to know about this SI unit, the SI unit is the mass flow rate. This is what we call the mass flow rate. So what I'm trying to say is that you are given the mass flow rate. We see it that by kg per second. So this is the mass flow rate. So now if this is the mass flow rate, the question that you need to ask yourself, what is the formula that we use to calculate the mass flow rate? The formula for mass flow rate, that is equals to the mass, which will be the mass of the water, divided that by the time. So we can use this formula to make what? We can use this formula to make that time subject of the formula. So the mass flow rate is given as, remember, it's 2.5. So this will be my 2.5. It's equal to the mass of the water is 200 over t. Let's find t. So this will be 2.5 multiplied by t is equal to 200. Divide both sides by 2.5. Divide both sides by 2.5. Therefore, what is t equals to? T is 200 over 2.5. When you punch this on the calculator, what do you get? So this is 200 divided by 2.5, and I have my answer as 80 seconds. So now that I have the 80 seconds as my time, I can use this time and substitute it on this equation to find the constant speed at which the water is lifted up. So now this will be 12.5 divided by 80, and what will be the constant speed? So when I put this on the calculator, I get my constant speed V to be equals to 0.16 meters per second. So now I need you to pause the lesson. Look at how I answered this 5.3.2. Try to find a way how I work around questions. Even if you can go back to some of the questions that we did, look at how I answer my question. I start by focusing on what I have, and then when I see that there's something missing, I find a way to find whatever that is missing. Look at this. My focus one was on constant speed, and the formula for constant speed is d over t. And now I know that this is the distance is 12.5. Then what is missing? The time. then I find a way on how to calculate the time. Look at this question on work, energy, and power. We just did our substitution. We find that VF is missing. We find a way to find VF. I think it's best if you work like that, né? Right. So now, when we... Oh, was this the last question? Nope, there's still 5.3.3. The average power, calculate the average power dissipated by the pump and ignore the energy losses in the form of heat and sound. So when they want the power, if they want the power, I'm just gonna first do my data on that 5.3. So for the 5.3.3, if I do my data, I'm just gonna check that they need power. Before I do data, let me go first and check the formulas that has P for power, and then I'll take it from there. So when I look at this, where is power? Electrostatics is power. Where? Under okay, energy, work, and power. Okay, it's somewhere here. Let's look at the formula for power. All the formulas that have power, P average, it's F over average, this one work. And then another power is this one. What is W on top? The W is the work done. Do we have the work done? Yes. Do we have the delta T? So the delta T is the time that it will take that guy to move up, and we got that as 80 seconds. And this one, I don't remember what was the work, but we did find the work. So the correct formula that we can use. Okay, I think this one is easy. I think this question is easy, so we don't have to do much explanation on that. We just have to choose the formula and do our substitution. So no need for data, because already we know that P is the work done over delta T, and the work done, I'm just gonna go back. Oh, it's even here. The work done by the F pump is 24,500 joules divided by delta T. We just calculated it to be 80. Okay, so now guys, I think it's a ding, because I think that physics questions are easy, but we're going to talk about why most of the learners lose marks. Né? Why is it difficult to get the marks that we need? Let's talk about that, guy. But first thing first, let's close this question and say 24,000 divided by 500 over 80. What is this equals to? So on my side, I got 306.25 watts if we round it off. So guys, the reason the questions are easy, and I think you guys can agree with me. But when we talk about why is it so much difficult for us to find the marks that we are looking for, look at this. When we started doing the calculations, we calculated the work, which is 24.2. So let's say we make a mistake somewhere on this 5.3. We lose these marks, and then how will this 2.4 affect our next questions? Let's work on that. Let's see. So this will affect 3.3 because we're going to do wrong substitution. Then when we do wrong substitution, what happens? Going another 3 marks. Pa. Okay? Then now this tells us that even if we do the 5.3 wrong and we don't manage to get this 80%, the 80, it will also affect that question. So another 3 marks going. So now this tells you that out of 13, we're going to get what? We're going to get 2 marks for definition, 2 marks for the free body diagram. Unless if you forget to name your forces, because you are too much excited and say, free body diagram, easy stuff. Then you say, pa arrow kodimo, pa arrow down, then you are done. You just leave it like that. They'll be like, and then what is this? You see? Yeah, I think that's why physics we lose marks. It's not like it's difficult. It's easy. Make sure that you take everything step by step. I don't like Doppler effect, you know? I don't like Doppler effect, but what can we do? We just have to answer it, né? Okay, let's work on this Doppler effect question. So they say that a bird emits sound waves with a frequency fs, the frequency fs, as it flies at a constant speed, and the constant speed is vb. So this is the velocity of the bird. Hey, why am I saying the bird? The bird. Okay, so towards a vertical cliff. So this is my vertical cliff. It is traveling towards that cliff. The wave reflected on the cliff with the same frequency, the wave reflected off the cliff with the same frequency that they strike the cliff, and with a wavelength of, this is the wavelength, it's given there as shown in the simplified diagram below. Take the speed of the sound in air to be 340 meters per second. Okay, and now name and state the phenomenon that result in the change in frequency of the detected sound waves. It's Doppler effect. Now just look at this. We know that this question 6 has to do about Doppler effect. So just state Doppler effect down and then try to name it. So this is Doppler effect. And what is the definition of Doppler effect? When you state it, the change in frequency. Doppler is the change in frequency. Okay, the change in frequency of the sound detected by a listener. By a listener. By a listener because the sound, and the source, because the sound and, okay, let's say because the sound source have different velocities. Guys, this is the best I can do. Now please try to consult your exam guideline on the definition. Has different velocity relative to what? To the medium of what propagation. That's the part I remember. So now have different velocities. Just try to go to your exam guideline and try to find the correct answer for that one. But we know it's something like this. Then 6.2, they say that on 6.2 show that Fs, which is the frequency of the sound waves emitted by the bird, is 21,250 minus 6.25 VB. So you know what I'm going to do? I'll focus on finding my Fs. So you know what we're going to do. Now let's work this thing down here. Let's work on it. I'm not sure if this will be enough space. Okay, this is 6.2. On 6.2, they want us to show, you know what I'm going to do first? Let's analyze what we given now. Let's talk about the wave equation. So I think we know what is the wave equation. Now, so the wave equation, we use the formula V is equals to F times the lambda. So if you don't remember how to you don't remember these formulas, hey, just go to the grade 10s, ask them, guys, I've done this like 2 years back, 3 years back. Can you please help me with the wave equation? But don't worry, after this lesson, after this, you're going to understand that wave equation part. So now we are looking for what? We are looking for, let's first find the frequency at a cliff. The frequency at the cliff, because if we look back up there, we have this, the reflected wave, so we can find the frequency at the cliff. Okay, let's see if this works. If we manage to prove this, then this is correct, guys. Let me just try to drink something. Maybe I'll be okay. Let me just try to put something. So we can complete this question, okay? All right. So let's make F subject of the formula. When we make F, we can divide both sides by the lambda, which is the wavelength, Therefore, my F is equals to V over lambda. So that's what we have now. So for the reflected waves at the speed, at the cliff, now we need to find the frequency. So I'm just gonna put it down here and say, for the reflected waves at a, for the reflected waves at the cliff. So my frequency, okay, let's start with the speed of sound. We are given the speed of sound. They said we should take it as 340. So this will be 340 meters per second. And then the wavelength, which is lambda, we know that it was given as the reflected wave. We have the lambda as 0.016. So I'm just gonna do this and say this is 0.016. Guys, just write what you are given, man, and then do the substitution. Just take this, you'll know what to do next. So the frequency, now we need to name this frequency. This is the F for the frequency. Okay, so this will be what? This will be the frequency at cliff. It's equals to V over lambda, which is from that formula there. And then now when I substitute V is 340, that guy, divide by the 0.016. Please punch that on your calculator. Therefore, we'll find the frequency at a cliff to be equals to, when I put this on the calculator, what do we get? Nice, 21,250 HZ. So now you'll see me smiling in an exam. You'll see me smiling because I know that this 21, I'm on the right track. Then you'll see me smiling, and they'll be like, see me like, that's when you start to sit well now, because you are measuring this question paper. So now, because of that, I'm going to start having like a confidence, because I can say that, you know what, I'm going somewhere, and not only somewhere, I'm going far. Right. So now let's work on this. So now that you have that, the frequency at a cliff, this frequency at a cliff, please guys, it's not your FS, it is not that FS. Right. why is this frequency not for that fs? Why is that the frequency, not the frequency of the sound waves? Because the bed is moving towards the cliff. I hope you guys understand that part. Né? The bed is moving towards the cliff. So this is not, this guy here, it's not the frequency of the source, because the bed is moving towards the cliff. So if the bed is moving toward the cliff, this tells us that the cliff receives a higher frequency than the one emitted by the bed. Okay, so now I'm going to write it down. Let's look at the problem. What is going on here? We have the source that is moving. So this is my source. This is my source, and my source is moving. And then we're going to have the we have the observer that is stationary. Which one is going to be our observer? The wave reflected off the cliff. Maybe I can consider my cliff as the observer. And the observer is not moving. So the observer, which is stationary. Guys, I don't know how they teach you Doppler effect at school, né? But what my teacher used to tell me is that first thing first, to choose the correct formula to use, number one, write what you know about the source. The source is moving, which is the bed. Number two, then say the observer. Tell us what you understand about the observer. The observer is stationary. Then, if the source is moving and the observer is stationary, the correct formula to use, let's go to Doppler effect and choose the correct formula. I think when we see this, we're going to remember this by looking at the formulas. So this is wave, sound, and light. So now, this is the formula. Né? These are the formulas. So because you are looking for Fs, I'm just going to focus on that formula. So this one, let's not think about it. Right. So my teacher used to say, think about this. The source, we said that the source is moving, and the observer is what? The observer is stationary. So this tells you that the velocity of the listener is going to be what? 0. So the velocity of the listener, which is the cliff, is 0 meters per second. And then now, if the velocity of velocity of this is 0, now let's talk about the source. The source is moving towards the what? The source is moving towards the observer. So since the source is moving towards the observer, the sign for this one, it will be negative. So if the source is moving towards, it will be negative. So let's go and write the formula, the final formula. I hope you guys understand how I chose my formula. So now I'm going to say that the formula to use is FL. It equals to V on top, because I know that the velocity of the listener is 0. So this will be equals to V over, and then this will be V minus velocity of the source, which is my VB. Why am I saying this is VB? Okay, fine. Let's write the formula first, then we'll do the substitution next. I think everyone will be happy about that. V of the source times Fs. Okay, so now we have the frequency of the listener at the cliff. The frequency of the listener, we just calculated this to be 21,250. So this, when we substitute, is 21,250, and then equate this to say V, we already know, is 340. I'll have 340 on top. This is divided by V, which is also 340, minus the velocity of the source. They said that this source, it moves at VP. So the velocity is VP, and I'll definitely substitute that as VP. Right. Multiply this by Fs, which is what we are trying to find. And then when it's like this, I'm going to say that we make Fs subject of the formula. And how can we make Fs subject of the formula? You know what I'm going to do? First thing first, to think about this, how can I make Fs subject of the formula when I have this? Maybe we can start by multiplying. Maybe we can start by saying 2150, 2125 is 2125, 21250. Let's multiply this by the 340, the 340 minus VB, and then let's say on that side we are left with 340 times Fs, because we this is over 1, we just said this times that and the 1 times that, so this is also over 1. So when it's like this, I can, if you don't understand this part, please pause, work on this problem. Now pause the lesson, work on this problem. So this is 2.1, this is that times that, and this is the 1 times what we have on top. But remember, this is over 1. First thing first, these two will multiply, and then this whole thing will be multiplied by that 1. Okay, so now I'm trying to move slow on that one. Then now we can divide everything by 340, divide everything by 340. Right, so when we divide everything by 340, what do we get? When we divide everything by 340, so I can see that I'll have Fs, these two cancels, and then I can write my Fs to be equals to, so now the question said prove that Fs it's equals to 2150. I want to teach you this thing to think, because some of the things they just straightforward, man. This is 21250 minus 62.5 VB. So now I know that whatever that I do, I don't have to do anything on this guy. I just have to leave it like that. I need to leave it like that. So I can rearrange my equation and say this is 21250. Then I need to leave it outside. So when I leave it outside like that, inside the bracket, I need to work out on the come on, how can I do this, madam? Inside the bracket we'll have 340 minus VB over 340. So I just arranged my equation there. So now this will give me Fs to be equals to 21,250. Inside the bracket, I can say the 340 divided by the 340 minus VB divided by the 340. Remember fractions, how fractions works. If we have one denominator and on top you are subtracting or adding something, if I have A plus B over C, I can write this as A over C plus B over C. That's what I applied on that step. That's what I did on that step. Then when we keep on moving, I'm going to say Fs now. It will be that 21,250 inside the bracket. This is 1 minus. So if this is 1 minus, I'll have this as VB over 340. What's next? Multiplying out the bracket by that 21. So this If we multiply out the bracket, we're going to say this times the 1 and this times everything there. Ne? Let's quickly work on that, guys. So now this will be fs is equals to, this will be 21,250 times 1, which is just 21,250. Then minus, I'm going to have the 21,250 multiplied by VB over 340. Okay, so what is my fs equals to? This is 21,250 minus, how many marks is this question? Maybe I'm the one making it more complicated, I don't know. So now this is 4 marks. It's fine, I need that 4 marks. I'll go all this trouble to find the 4 marks. So 21 minus, so now I know that I can just say 21. When I multiply by this, it will be 21 divided by 340 times VB. So I can write this as 21. I'm just going to write it down here. I can say this is 21,250, divide that by 340, and then multiply that by VB. And 21, what is, if we punch 21,250, we need to get the answer as 62.5. Let's put that on the calculator. So when I put this on the calculator, I find exactly 62.5. Now I'm smiling. Now I'm smiling. It's a ding ding ding. Guys, sir, you said you don't like Doppler effect, but you are explaining it nice. Guys, I just don't like, if I don't like it, I don't like it. But to teach it, there's nothing wrong with teaching this topic. I can just make you be the best. Ne? There's nothing wrong. I just don't like Doppler effect. Ne? So now let's work on the next question. 5 marks. So this tells me that we're going to work on more calculations. Yes. Another 5 marks. Calculate the frequency of the reflected sound waves detected by the bat. It's 850 Hz, higher than the frequency of the sound waves emitted by the bat. The frequency of the reflected sound waves, the reflected sound waves detected by the bat, it's 850, higher than the frequency of the sound waves emitted by the bat. Calculate the speed of the bat, which is VB. So let's first analyze what is the question saying and where are we going to write that. We don't have a space. I'm going to cry. We don't have a space. Should we go to the blackboard? Yes, let's go to the blackboard now. Let's duplicate that. Let's take everything to the blackboard. So I'll go back, read the statement, then come back and write what I understand from the statement. They say that the frequency of the reflected sound waves, the frequency of what? The frequency of the reflected sound waves. So what I'm going to do, I'm going to say F detected, which is the frequency so F, the frequency that is detected, it's equals to, and the statement is saying the frequency of the reflected sound waves detected by the bat is 850 Hz, and that should be higher than the frequency of the sound waves by the bat. So this tells me that this is going to be Fs, which is the frequency of the source, because they said the one that is detected is higher than. So F detected, we need to add that 850 Hz. I hope this makes sense. So from this, we know that F detected is equal to Fs by times 180. Please pause the lesson. Make sure that you understand why we are adding those two. The frequency of the reflected sound waves detected frequency is going to be 850, higher than the frequency of the sound wave. So the frequency of S plus 850, because F D is equal to that. F D is 850 higher than the frequency. So it's going to, we take Fx, we add 850. I hope this makes sense. Yeah? So now, when it's like this Doppler effect, it happens again. Please, let's go back to the question. Look at this. After the reflection, the cliff acts like a stationary source, and we did write it down. So if it acts as the stationary source, it sends back the sound. So it's going to act like the stationary source, sending what? The sound back. Now the back is moving where? The back is moving towards this reflected sound. I hope you guys see. It's even there on the diagram. The back moved towards that reflected sound. So this tells us that the bird is going to detect a higher frequency. And then what is this? We need to write down the formula for a moving observer. Let's go and write it down. So the formula for a moving observer, we set F, we need to find F detected, and I'll say this is, remember we said that this is V. So if this one for a moving observer, this will be V plus this time we say VB, because this one is not 0 and this is divided by V. So if we go to the formula sheet, you know why I don't like this Doppler effect question is this choosing, because if the equation that we choose is wrong, we're going to have a lot of problems. You see now? So now look at this. We need the formula of what? The formula of the moving observer. So we need the formula for the moving observer. So now we know that the listener this time, this will be, what are we saying? The velocity of what? Of the moving observer. So now if this is the formula that we use, the velocity of the source, what is the V of the source? Is just 0, because the observer this time is the one that we're going to focus on. So I think instead of Fs, you see why I don't like Doppler effect? Maybe someone might forget to say this is Fl, because we're going to use the frequency of the listener. So what I'm trying to say, this changes and is going to be my F of what? F of D, which is detected. This is F of S, and then we equate these two. On top, we're going to say V plus my VL is the velocity of that moving source. So it's going to be VB, it's not 0, over, because you are using the frequency of the moving source, the V detected. And then this is divided by what? This is divided by, this will be 0, and we just divide this by B. But now when we multiply this, make sure that you use the formula. Instead of Fs, we need the frequency of the listener. Right, let's go to our blackboard and write that down, guys. I hope you understand why. You understand the formula that I did. But if you don't get it, it's fine. We still have marks. You're going to eat. Don't worry. Now, so this will be the F detected. It's equal to this formula, then multiply that by the frequency of L, and then now we can do the substitution. If you still remember we just calculated, we know that F, the frequency of, what is this? The frequency at a cliff, it was 21250. So this is my FL, this guy, the frequency of the listener. So my FL, it's equals to 21250. Okay, I hope everyone is happy on that. So let's do the substitution. So the frequency detected, it's equal to the speed is 340 plus we are looking for VB. This is divided by 340 multiplied by FL. We know that FL is 21250. So now we just have to work this thing out, because now we have two unknown, né? The two unknown, F detected and the VB, and we are looking for VB. But if you still remember we said the F detected, it's equals to Fs plus 850. Okay, so now if it's like that, we can just substitute this on the formula. So where there's F detected, right, look at this, where there's this guy here, we can substitute what? The Fs plus 850. I'm not sure if we do it like that, it's going to be the best for everyone, but this is the only way to do this. Now, this is the only way. So when I do this, and I don't think of this, the way I answer my questions, you can get my solutions to be the same as the ones on the memos. I don't think so. But you know what? What I know is that these were the answers that I was giving them, and they were giving me full marks. So Luena, you can do the same, because if you check the memos on past papers, some of the answers are very short, and you'll be confused to ask yourself, where is this coming from? Where is this coming from? So that's why we struggle to study even when we have the answers. We have the memo, and this is the question, but it becomes more difficult for us to study. So what I need you to do, please don't depend on the memo, né? Because there's nothing on the memo. The memo is very short. Where's my SP pen? You see, guys? Okay, so now we can substitute that and say my Fs plus 850, it equals to 340 plus VB over 340. So this is multiplied by 21250. Okay, so now when I have it like this, I think this becomes another issue that we can fix it like, then it will be a ding ding ding. So this Fs, if you go back to your, let's go back to what we currently worked on the previous equation, we proved that Fs, let's do this with a different marker. So we proved that Fs, it's equals to 21250 minus 62.5. I never thought we're going to no, we are not wasting time, we are learning. But I never thought that we're going to spend so much time on Doppler effect. So Fs, if you still remember, I'm just going to put it down up here, that my Fs is equals to 21250 and then minus 62.5 VB. So if I substitute my Fs, this tells me that I will only have what? I'll only have VB to calculate. So my Fs is 21, my Fs will be 21,250 we minus 62.5 VB, then you add that 850, né? You add that 850, equate this to 340 plus VB over 340, and then this is multiplied by 21250. You know, I'm busy laughing because now that we are on this step, and then when we are on this step, there's only VB on the equation. We just have to use the algebra. I know that someone who's watching this lesson is like, you know what, sir? I got this. I can take it from here. Okay, guys, it's not easy to get here. You have to think. But now I'm just laughing when making this lesson now. And I'm saying that someone out there now is saying, you know what, sir? Just leave this one up to me, because now I know that I can add this like terms, and then whatever that I get, I can move the VB to the outside. What? Okay, let's try to take this step by step. Now, so let's rewrite this equation down. Then we're going to take it. Then you can take it from here. Then I'm just gonna let you take it from here. So you know what you can do? Pause the lesson. Take it from here. Let's see if you can get the same answer that we're going to get by the time we finish solving the problem. So this is equals to 340 plus, yeah, this is you guys, I'm laughing, you know that. Yeah, okay, so I can take it from here, 21250. Okay, so now so when I have this, let me simplify the left hand side first. Né? I think I can simplify. I can start by simplifying the left hand side. Or can we start by simplifying the left hand side? Let's simplify the right hand side first and see what we get. So if I simplify the left hand side, remember the 340, we can write as 340 over 340 plus VB over 340, and everything here is multiplied by 21. Okay, let me do this. Right hand side. And then this is 21250. So this is 1 plus VB over 340, and this is 21250. So now when we multiply out the brackets, we get this to be 21250 is 21250 plus what? Plus, guys, we multiply the bracket is going to be like this. I think we did this on the previous lesson. 21 times that is this, and then we say we multiply this by that. I know that this is going to be 6.25. So let's quickly write this down. So this will be plus 6 what? This will be plus 62.5 VB. Right. So this is my right hand side. So let's take this right hand side and do what? Should we equate this to the left hand side? Yes, we can. Let's just say this guy. You see, I'm very sorry guys about the background noise. Unfortunately, where I stay, we just there are no rules, so you can do anything you want, and now no one can say anything to you now. So this is the right hand side, and then when I have it like this, I'm going to say equate the right hand side to left hand side. But before we do that, let's add the like terms. Now I think before we do that, let's add the like terms and say, should we add, do we even have the like terms? Nope. You know what why I'm not going to do to add them, because I know that these two will cancel. So let's say I have 21250 minus 62.5. Okay, let me quickly work on this. Okay. You see, if I was brave, I was gonna just go each and every room and steal like those speakers. Each and every time you buy a speaker, I steal it. Each and every time you buy another one, I steal it, because now I need to teach when you always have your music on. You see, I'm very sorry guys, but let's continue the lesson. So this will be 21250 minus 62.5 VB plus 850. I equate this to 21250 plus 62.5 VB. I say you always make your solutions long. Okay, it's fine if I make my solutions long. These 2125 and 2125, they are on different sides. So when we bring the other one to the other side, they cancel. This is what you guys want me to do. Okay, I'll definitely do that. The 625 and the 62.5, these are the like terms. So I need to bring them on one side and then add them, because now the one is negative on the right hand side and the one is positive. So when the other one goes this side, it will be positive 62.5 plus positive 62.5. So this tells me that this side I'm left with 850 is equals to, I take this and add with that, which will give us 125 VB. Is that what you guys want? Let me give you what you want. Divide by 125, divide by 125, therefore what is your VB? The answer that you get is your velocity. So it's 850 divided by 125, then the velocity, I got 6.8 meters per second. .8 meters per second. And that's it for this Doppler effect. Get in, it's a ding ding ding. Let's see what we have on the next question. Electrostatics. Okay, let's see what we have. Question 7. Start on a new page. You see now? Okay, let's check what we have on this question 7. A small negative, we are given that a small negative charge Q is placed at a fixed distance from the charged sphere Q. We can see the diagram experience a force F as shown in the diagram. The charge Q is now removed. Draw the electric field pattern for the charged sphere Q. So I need you guys to read the diagram carefully, and I'm going to assist you how to read this diagram carefully. So now let's work on this. So first thing first, I'm going to give you guys a lot of notes. So number 1, what do we see about sphere Q? Sphere Q is on the left. So I'm going to write left here, and then small charge Q is on the right. So this one is on the right. That's what we note so far. So now small charge Q is negative. This guy here is negative. That's what we know so far. And then the force on Q is pointing to the left, which is towards Q. We can see that this one, where is this pointing? Left. The arrow is to the left. So now, after reading this diagram carefully, we need to decide whether the force is attraction or repulsion. So how can we do that? Remember that because the negative charge Q, this charge Q is pulled towards Q, the force is attraction. But if it was going away, the force was going to be the force of repulsion. So the force is attraction. I'm just going to write that down. Because the small charge Q is pulled towards Q, this tells you that this is the force of attraction. But if it was moving away from Q, it was going to say it is repelling to Q. But now it's moving towards Q. This is the force of attraction. Guys, just give me a second. I know that, say, they said draw. What are you doing? Where are you going? Why don't you just put the drawing? No, I won't put the drawing. I won't give you something that you don't understand. Please make sure that you stay with me on this. By the time I'm done explaining this, everything will start making sense. So remember, so since this is the force of attraction, we know that attraction happens between opposite charges. So the attraction happens between opposite what? Honey, what is this, the spelling of opposite? Opposite charges. Right, I think now you see where I'm going with this. Nah? So we said this is attraction. So this tells us that this is opposite charges. So we can therefore say, since Q is negative, therefore we said this is negative, this will make this Q to be what? To be positive. Right. So now we're going to use this information to decide the electric field pattern. So the electric field lines, remember, the electric field lines, they do what? The electric field lines, they point away from what? They point away from positive charge, and they will point towards negative charge. Right, so look at this. Q is positive. So if this is my Q, which is positive, the electric fields, they will point away that Q. So they will go out of the negative. They'll point away. They'll point away. Give them this drawing, you'll definitely get your 3 marks. But now, why is this 3 marks? Okay, it's fine. It's fine. Just give them. Maybe there will be the marks for saying Q is positive. 1 mark. I don't know, but it's fine. The correct shape, maybe there's a mark for that. Straight lines, a mark, I don't know. I don't know how they do this one, but the only thing they're interested in, I think, is the positive and the direction, and that's your 3 marks. Congratulations if you understand this. Now, you have your 3 marks in an upcoming exam, if they ask it in this way. So now let's go to 7.2. Sphere S is attached to the ceiling at point P. We can see that. And then by a light intensity ball string, when sphere R on an insulated stand. Okay, sphere R is on in an insulated stand. We can see the stand then, and then they say that is brought to close to sphere S, they repel, and sphere S comes to rest with the horizontal distance. So they think that they bring this close to that one, then they repel. This one goes in another direction, this one goes in another direction. So I'm just gonna, I feel like I'm moving fast now, right? Let me underline the word repel. Okay, so they repel and sphere X comes to rest with the horizontal distance between the center of the spheres is 0.3 meter. We can see that sphere R is directly below point P. The string makes an angle theta with the vertical as shown in the diagram. State Coulomb's law in weights. Do you guys want me to state Coulomb's law in weights? It's fine. Come on, guys. Coulomb's law. The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product. Guys, I'm just gonna give it to you in weight. I'm very sorry. Please go to consult your exams guideline. So F is equals to Q1 Q2 all over R squared. And then if I still remember, the formula correctly, this should be K. Right, this is Coulomb's law. So we are saying the force is directly proportional to the charge and inversely proportional to the distance between them. That's Coulomb's law. Let's work on 7.2. Let's see what we have on 7.2. They say draw a labeled free body diagram showing all the forces acting on sphere S when it is at rest. So this sphere S, it's not moving, it's at rest. So now they said that if we go back to the repelling weight, they said these two guys, sphere S, they repel. So now if they repel, this tells you that for S, the electrostatic force for S will move in that direction. So this is the force of electrostatics. Let's call this Fe. And then now this F has that, I'm not sure if we can call this the rope or we can call this the tension. Do we have the rope? Maybe let's use that for tension. But remember, the sphere S, it will definitely have a what? The weight of Fg. So if we draw a free body diagram for that guy, if we draw a free body diagram, the free body diagram will look like this. For 7.2.2, the free body diagram will be electrostatic force in that direction, and then the tensional force going that side, the weight going down. And that's it for this question. Easy 3 marks, ne? So a sphere R has a charge of positive 6 nanocoulombs. So this is positive 6 nanocoulomb, and this one has positive 3 nanocoulomb. And the mass, this mass, it's what? I'm just gonna convert that just to save myself from forgetting converting the mass. The mass should always be in meters per what is this in meter. So what is this? How do we convert from grams to, the mass should be in kg, né? The mass should be in kg. So I'll take that 0.15. The 0.15, I'm going to divide that by 1000, né? From grams to kilograms, we divide by 1000, and what do we get? Am I right when I say we divide by 1000? Yes, we divide by 1000 from grams to kilograms. Then we're going to divide that by 1000. So if we divide by 1000, we get this as 0,00015. So that is my grams in kg. Get in. So now the question says calculate angle theta for 5 marks. So go back to the diagram, try to understand what is angle theta. This is my angle. So now when you have this type of question and you want to find angle theta, make sure that you use this 3. Please listen to this. Né? What I'm giving now is very good. Né? Use these 3 forces to create what we call the vector diagram. Then on the vector diagram, make sure that it is that theta inside. So I'm going to teach you how to do this. Né? I'm going to teach you the easiest way. Look at this. Fg is going down. Né? So since Fg is going down, this tells me that I can move this Fg here and take it from that point P and write it down there and say Fg is going down, because I need to create head to tail method. Né? And then Fe is going in that direction. Remember we said from vector when we use vector, the arrows that you see on the free body diagram, they will be the same on the vector diagram. They will point in the same direction. So now this tells you that we need to take this point. This is the starting. If you still remember what we did on was it the yesterday's lesson or is today? What is this? This is physics. No? Let's quickly go back up. I think we did something like this. I'm not sure if it was our previous lesson or this is the lesson. Okay, I guess it was our previous lesson. Or is this, get in. This was on the multiple choice question. This was on the multiple choice question. Remember what we talked on the multiple choice? Each row must start where the previous one ends. And then the last vector must bring you the starting point. Let's go back. Guys, I'm sorry when I say it was yesterday, today, because remember I'm not taking like one day to record this lesson. As you can see, if you can check the time, these are different times. So I take breaks and so on. Right. So when it's like this, let's quickly work on this. So you know what I'm going to do? I'm going to say that, the FE should be on top of that arrow there, and it's point in that direction. And then this one, the head of the tension, should be on top of that one, and then it will go in that direction. So can you see that the arrow takes us where we started at that point? It takes us where we started. So now, when it's like this, I know that this will be my hypotenuse, which is, this is 90 degrees now. So this will be my R, and then if this is my theta, this will be my X, and this will be my opposite, which is Y. So let's quickly work on that. Let's quickly work on that. I'm just going to move my diagram here and redraw my diagram. So I'm going to say I have the force of Fg going down. So this is my Fg. Then in that direction, this is my electrostatic force. Guys, you are lying. I make this easy now. And then this is what, this is my tensional force, and we said this is angle theta, this is 90. So we'll refer to that diagram. So now they said that they want us to find angle theta. So I think when I look at this diagram, can I find tension? It won't be easy for me to find tension, but it's easy for me to find this guy because it's the electrostatic force. I can use the electrostatic force formula to find Fe. So what I'm saying is that I can use the electrostatic force and say that Fe is equals to the formula for electrostatic force is K of Q1 Q2 over R squared, and we are coming back to that. Let's just leave it like that. We can find this guy easy, and we can find the weight, which is Fg. So we can find Fe and we can find the weight as mg. I think we can use what? We can use opposite, which is y, and adjacent. Then we'll go to SOHCAHTOA, or you guys call it SOHCAHTOA, whatever. The most important is not to pronounce it, but the most important thing is for you to know how it works. So we say that we have y, which is opposite, and we have x, which is adjacent. So we're going to use the one that has O and A, which is the tan. So this tells me that to calculate this guy, I need to use the tan of theta is equals to opposite, which is y, and my opposite is Fe. Divide that by what? Divide that by my adjacent, which is Fg. So now this tells me that I know what I need to do. My next assignment or my next mission is to find Fe and Fg. That substitute that, then solve for theta. Let's work on that next. So my Fe, what is Fe equals to? So Fe will be Fe, it's equals to, let's write this down. What is this question for? 7.2.3. So this is 7.2.3. So Fe is K. We know that this is a constant, which is 9 times 10 to the power 9. Close the bracket. Q1, the first charge, it was 6 nanocoulombs. Remember, if it's nanocoulombs, we multiply that. So if it's nanocoulombs, we multiply by 10 to the power negative 9. So we need to take the 6, multiply that by 10 to the power negative 9, close the bracket. I think we don't have much space, so what I'm going to do, I will rewrite my equation. let's rewrite that equation. Okay, so we are saying that Fe it's equals to, I'm trying to make sure that it fits here. Fe it equals to 9, which is k, times 10 to the power 9 times 10 to the power 9. Close the bracket, then this will be 6 times 10 to the power negative 9. Then the second charge is this one, 3 nanocoulombs. That will be 3 times 10 to the power negative 9. Close the bracket. Then everything is divided by the distance between them, which was 0.03. Right, so this will be 0.03, and the 0.03 is squared. So what is Fe when you punch that on the calculator? I know that most will struggle to put this on the calculator. I'm also putting this on my calculator. I have 9 times 10 to the power 9, 6 times 10 to the power minus 9 times 3 times 10 to the power minus 9. Everything is divided by 0.032 squared. So I get my answer as, if I put this in scientific notation, it's 1.8 times 10 to the power negative 4 newtons. So this is my Fe. So now that we have Fe, what is the next mission? Is to find the weight. So Fg it's equals to mg. So we're going to use the mass that we just converted, which is 0.05. So I don't think, even if you put this in scientific notation, you can write that as 1,5 times 10 to the power, how many zeros do you have? 4. So it will be 1.5 times 10 to the power negative 5 and negative 4. That is the mass. So when it's like this, we can substitute and say Fg is equal to the mass of 1.5 times 10 to the power minus 4 times g, which is the gravitational, which is 9.8. So what is your Fg equals to when you put that on the calculator? Oh, by the way, this is the last question. This is the last question. So Fg it's equals to, when I put this on the calculator, I get this to be 1.47 times 10 to the power negative 3. So basically it's 0.00147. So this is to the power negative 3, and it's in newtons. Let's substitute now to find theta. I think this makes sense. I think everyone is happy on how we got the Fe, and I think everyone is happy on how we got that Fg. Right, so when I have it like that, I'm going to say that the tan of theta is equals to, I'm not sure since this thing is in scientific notation, to remove it down here. Let's move it down here. We said that the tan theta is equals to Fe over Fg. So let's substitute. The tan of theta will be, what was Fe? We calculated Fe to be 1.8 times 10 to the power minus 4. So this will be 1.8 times 10 to the power minus 4. Divide that by, we set Fg, it's 1.47 times 10 to the power minus 3. So this will be 1.47 times 10 to the power negative 3. Therefore, when we have this, I'm just going to leave it at this and say theta, it's equal to the tan inverse of everything. The tan inverse of that 1.8 times 10 to the power minus 4 over 1.47 times 10 to the power negative 3. Right, so when it's like this, what is angle theta equals to? So the angle theta, it's equals to, let me quickly put this on my calculator and see what I get. Inverse 1.8 times 10 to the power negative 4, everything divided by 1.7 times 10 to the power minus 3, and this gives me theta of 6.98 degrees. And that's it for this question. This will be the last question for this question 7. I hope you are happy about the steps that we did to find the 13 marks. It's a ding ding ding, get in. So let's go to question 8 and see what we have on question 8. Question 8, they say in the diagram below, we are given that the battery has the EMF of 24 and the internal resistor of 0.3. So the light bulb L has a resistance of 9.5 and R is a resistor of an unknown resistor. Ignore the resistance of ammeters and connecting wires. We can see the diagram, blah blah blah, state Ohm's law in weights. So I think now you can even see that we don't have much energy for these definitions, and I believe that you guys can find the definition on your exam guideline now, because guys, it's been a long this is a long lesson, and let's just say that Newton's law said V is equals to IR. Reason, remember the potential difference across a conductor is directly proportional to what? To the current in the conductor at a constant temperature. Just give them that and you'll get your 2 marks. When both switch S and S2 are closed, so this switch here and that switch there, we close those 2 switches, what happens? The reading on ammeter A1 is 0.8, so I'm just gonna write it down here. It's the reading there is 0.8 amperes. Okay, so now calculate the current through the light bulb L. They want us to find the current through the light bulb L. You know what I'm going to do on this problem, how I'm going to answer this problem. So to find the current through the light bulb L, I'm going to say for this question 8, okay, for this question 8.2.1, first thing first, let me try to analyze this question correctly. They want us to find the current on this bulb, and I know that the formula that we're going to use is V, it's equals to the current times the resistor. But now let's write this properly and indicate what is this current for. It's for the light bulb L, so that you don't get confused and use the total current. So this will be the current of the light bulb, then we're going to multiply that by the resistor. We're going to talk much about that. We are coming, and the resistor is given there as 9.5. Right, we have the resistor, we are looking for that, but we don't have this, the voltage across what? Across that parallel resistor. So we need to first find V. That's the meshing. So now this will be V, it's equal to the current of L into 9.5, because 9.5 is the resistor. You see, this is how I attack the question. 9.5 is my resistor. Now I know what I need to find to calculate the current of the light bulb. I need to find V. So now, what I need you guys to note in mind is that, remember that when you work with what is this? I'm going to use Ohm's law. I'm going to use Ohm's law and say that, okay, how can I put this? I'm trying to say I'm going to use the parallel idea, because this 13 resistor here and the resistor of the light bulb. So the 13 resistor, okay, let's say the 13 resistor and the light bulb, they are connected in parallel. So this is parallel, this is parallel. So these two are connected in what? In parallel. So since they are connected in parallel, so we know that in a parallel circuit, so in a parallel circuit, what do we know about parallel circuit? Is that the voltage V is the same. V is the same across what? Across each branch. Okay, we are happy about that. So the voltage across the BL will be what? We need to find the voltage we can first find the voltage. So that passes through this point. So we're going to use this information there. I'm going to use this information here. The voltage through that branch is going to be the same voltage through that part, because these two guys are parallel. So first thing first that I'm going to do is to find the voltage on that, let's call this X, let's call this Y, the voltage for the X branch. So let's quickly find that. So V is equals to the current times the resistance. So the voltage is equal to, what is the current? It's given as 0.8. This will be my 0.8 multiply that 13 resistor. So this will be multiplied by 13. So the voltage, when we multiply these two guys, we get this as 10.4 V. So what we are saying is that in parallel circuit, V is the same across each branch. So I'm going to say the voltage for Y branch is equal to the voltage for X, and it's going to be equal to that 10.4. So to find the current, we're going to substitute that V as 10.4. So I'm going to take down my formula here and say V is equals to the current of L into 9.5, and then when I do the substitution, this will be 10.4, the current of the light into 9.5. Then what's next? Let's divide both sides by that 9.5. Divide that by 9.5. The answer that we get is the current of the light bulb. Then you'll have that 4 marks. Oh, we are collecting the marks. Got like we are taking all the marks. This is 1.09 amperes. Got we are taking all these marks like like Sambo. Each and every question, Sambo. Each and every question, Sambo. Each and every question, Sambo. At the end of the question paper, it's a ding ding ding. Okay, let's see what we have now. What is the next question? They want us to find on 8.2.2, they want us to find the reading on the ammeter A2. The reading on the ammeter A2. So I think it's best if, okay, let's look at where is ammeter A2 now. Boy, now look at this. I need you to be smart about this now. Please be smart about this. What is A2? Can you see that the current that passes A2 is the total current? So this is my A total. So A2 will read the total current. So if A2 will read the total current, to answer this 8.2.2, I'll say that my total current, I need to take, to find the total current now, look at this. Let's call this the current of the 9 resistor, or let's call this current 1. So current 1 and the current that passes through this point, let's call it current 2, and the current that passes through the light, let's call it current 3. So guys, this is how current works. So when the currents get to that resistor, this total current was splitted through those resistors, né? Then it comes back to this point as a total current. So it passes this point as an IT, I total. Then when it reaches this point, this is where I'm not sure if it's going to move in this direction or that direction, but it has to do with the concept from positive to negative or negative to positive, where you have to understand that between these two guys, which one is positive, which one is negative. That's not what we need to focus on this lesson. So now I know that if I can manage to calculate the current for this, the current for I2, and the current for I1, I can add all these 3 currents to find my total current, which is the current that will be reading by A2. So let's quickly work on that. So I'm going to say my I total, IT is equal to I1 plus I2 plus I3. So I think now I can find my, let's work this step by step. What is the current at, we know, what is the current at, hey guys, I'm very sorry, the noise is too much. I'm just gonna wait a little bit. Okay, so when we work on this, I'm just gonna check that I need to find my I total, and then we said we're going to find the total resistance of those currents, A1, current 1, current 2, and current 3. Né? So I think it's going to be an easy thing for us to do, because already we know the current for what? We know the current for the second one. So let's quickly work on this one. Né? Let's quickly work on this one. So what I'm going to do, I'll say that first thing first, I need to find you see, I get distracted. So let's start with the first current, which is 9 for the 9 resistor. Let's calculate the current for the 9 resistor. Let's start there. So remember, we said the voltage is the same across. The voltage is the same across each branch for parallel. So we can use that in advantage and say VP, it's equals to the okay, the current, the voltage for the parallel is the one that we're going to use to find. The voltage for parallel was, what was that? It was, we did calculate this, 10.4 net. So we're going to use that 10.4 V, which is the V parallel, is the one that we're going to use for the 9 ohm resistor. So let's quickly substitute and say the voltage is equals to the current of that 9 resistor, which is current 1. We need to multiply that by what? We need to multiply that by the resistor. Okay, let's do the substitution. This will be 10.4. It equals to the current 1 into this is 9. So I'll just substitute 9. Therefore, divide both sides by, we're going to divide both sides by that 9 to find the current. Therefore, what is my current? 1. The current 1 is going to be 10.4 divided by 9. That's 1.16. 1.16 amperes. So this is the first current, and then I'm going to substitute here and say my IT is equal to, I already have 1.16 plus The I2 is already given as 0.8 if you still remember. So I'm going to add this with 0.8. Then the current for this one, for I3. Do we know what is I3? Yes, we do. We did calculate the current for the light bulb, and I think it was 1.09. If I still remember this one, this was the current for the light bulb. I'm just going to substitute it and say this was 1.09. I think this one was an easy one. So when we add this three, what do you get on your calculator? This gives me 3.05 amperes. So now look at the marks. They start from 3, now it's 4, now it's 5. This tells you that the question keeps on improving. So the resistance of a resistor R, we need to find the resistance of a resistor R. So this is my R that we're going to look for. This is the R, and we need to find the resistor of that. So you know what I'm going to do? Let's analyze what we have. Unfortunately, we don't have space for this now. We used all the space, guys. Where are we going to work this question? I don't want to go to the blackboard, because we'll be going like left hand right, and someone is going to lose interest and get more confused. So let's try to just put it somewhere. So the resistance R, I know that to find the resistance R, I'm going to use the formula that says this will be 8.2.3. The formula that I'm going to use is V is equals to the current times R. But now the V, this V here, what is that V? It's going to be the V of R. We need to find the voltage of R, and then the current that we're going to use. The current that we're going to use is the total current, because R is going to read the total current, which is the same total that will pass through A2. So this tells us that the current is something that we already have, which is 3.05. So this will be the current of 3.05 times R. We are looking for this. We don't have that. So we need to find the VR. So this is where now we have the direction. Guys, I'm going to squeeze this thing like all over the question paper. So how can we find R? So what I need you to understand is that we can find the V external. We need to find the voltage of R. So we can use the formula that says V external, the formula that says V external. So V external is equal to V external. We take the voltage for the parallel one, then we add the voltage for the resistors that are in series, and there's only one, which is R. So I'm just gonna add this to R. So now, do we know the V external? Is the V external given? Nope. Is the V parallel given? Do we know what is the V parallel? Yes. Because remember, the V parallel is the one that we calculated as 10.4. So this 10.4, that 10.4, this one, it's my VP, my V parallel. So this is 10.4. So I'm going to, what's going on? V external, it's equals to V parallel is 10.4. This is 10.4 plus, we're going to add this to VR. So now what is going on here is that we are looking for VR, but we don't have this. You see? So now this tells me that I need to leave the formula like this. Guys, I'm not sure, are you following? Unfortunately, you guys can't answer me, but what can I do to solve this? Okay, it's fine. Let's continue. We don't have that, the VR, but now the next step is to find V external. So remember, V external, we can use the EMF to find the V external. So I'm just gonna work this thing up here. So let's put this thing down here. Guys, I'm very sorry. Let's go to the blackboard now. Let's go to the blackboard and try to analyze this step by step. Number one, we said that V is equals to I times R, and when we substitute, we said this guy, the voltage that we are looking is for R, which is equals to this I, we said is the IT, the I total times the resistance that we are looking for. So now, when we did that, we said this is VR is equals to, and we substituted that as 3.05, and this is R. Right. So now when it's in this form, what do we do next? We need to find we said what we're going to do next. Let's quickly go back, and you see now, that's why I didn't want us to go like this side, this side, this side. So far we have this, and then we don't have R. We are looking for R. Now we need to find the VR. And we said to find the VR, we'll use the external one. We'll say V external. Even the music, guys, it's really disturbing. I don't want to lie. I'm not sure how this goes on your side. But unfortunately, we have to finish this lesson. Hopefully, you guys can hear me on your side. So this will be V what? This will be V external. It equals to V parallel plus the V of the R, because it's the only one that is in resistor. And we said that the V external, it's equals to my V parallel, which was 10.4 when we were doing the calculation, and this is VR. What are we looking for? So the one that we are looking for, I'm just gonna put it as what? As a question mark. So this is what I'm looking for, but I don't have this. So now I'm saying that to look for the V external, what I'm going to do, I'll use the EMF. So EMF, let's just say E. You just have to get the formula on your formula sheet. So E is equal to the current multiplied by R times small r. So let's do the substitution. If we continue working on this will be equals to, let's multiply this guy. Now. So I times R, it gives us IR plus I and small r. So E is equals to, this is your V external plus this will be your V internal. Right. So let's substitute. We know that the EMF was given on the paper. Let's go back and verify. What was the EMF? The EMF was given as 24. So I'm just going to substitute that EMF as 24. So this will be 24. It's equals to V external. It's what we are looking for. Plus the internal one. So the internal one, the V internal, we can definitely find that because we know that. Let me go back and change this. Now let's write this as that IR, because we have the total which was 3.05. 3.05, we can multiply that with the internal resistor, the small one. So the total was 3.5, which is that guy, and then we're going to multiply this with the small r. I hope you guys are following. So now this will be the small r is 0.3, because the aim is to find the V external. So let's isolate that. 24, this guy will come this side to be negative 3.05, which is multiplied by 0.3. Whatever that we get will give us the V external. So now you just have to work that guy on the calculator and let your calculator do the magic. Then what is 24 minus 3 times minus 3.05 times 0.3? So when I put this on the calculator, what I get is 23 23.09 V. So I think we are almost there, because if I look at this, we have the V external so far, and then we can go back to where this equation to substitute the V external that we just calculated. So now my V external, we said it's equal to 10.4 plus VR. We need the voltage of R. Then we have the V external as what? As 23.09. This is 10.4 plus the VR. So the 10.4 goes to the other side to be 23.09. We minus that 10.4. This is equals to VR. So when you punch this two on the calculator, the voltage of R is equals to what? The voltage of R is equals to 23.09 minus 10.40. This gives me 12.69 volts. 12.69 volts. Okay, so now when I look at this, guys, so for the fact that we've managed to get the 10 point, we've managed to get our VR. We take this VR, we substitute it back there. So this is my VR, and I need to take it back to that VR to find my R. So I think you guys understand the pattern, how this works. Now, you start by listing what you have and what you don't have. Then each and every time you calculate something, you go back to the formula. We calculated this, we go back that. Then now that we substitute, we calculated this, we go back that. I think you guys understand how this works now. So now what I'm going to do is that I need to substitute my VR on the formula. VR is equal to 3.05 times R. So now where there's VR, I can put 12.69. It's equal to 3.05 into R. So this is what I have so far. I can just divide both sides by 3.05 divided by 3.05. You see, now I'm having so much fun. So what is the value of R equals to when you divide both sides? Okay, when I divide this, I get my RS. If I round it off, R is 4.16 ohms. Get in. It's a ding ding ding. Okay. Now, what is the next question? For 2 marks, switch S is now opened, while switch S1, switch S2 is now open, while switch S1 remain closed. How will this affect the reading on A2? What's going on? They say switch S1, S2 is the one that is opened. I'm trying to clear the space here so we can do the magic, because that's what we do. That's what we do best, magic. But now look at this now. Switch S1, it's opened. So if switch S1 is open, let me think about this. How is this going to affect the circuit? What happened if switch S2 is open? The branch with A1, you see this branch is removed from the circuit, because by removing the switch, nothing will happen in that part. So one parallel branch disappears. So this guy will disappear. So it disappears. Right. So now let's go and analyze on A2. What will happen to the ammeter on this A2? Because one branch disappeared now, how is this affecting A2? What does A2 measure? That's what you need to ask yourself. What? Because the question is saying, how will this affect the reading on A2? Right. So that one disappears, and how this affect A2? We can see that we need to ask yourself, what does A2 measures? So A2 measures the total current of the battery. As you can see, it measures the total current. So what I need you to ask yourself is that what happens to the total resistor? We can use Ohm's law to answer this guy now. We can use Ohm's law to answer this. So we have, let's say, how will this affect the reading on ammeter A2? Choose, increase, decrease, or remain the same. We are coming to that now. So let's use Ohm's law. I know that from Ohm's law, I is equals to V over R. So now look at this. If the resistor increases, the current decreases because the current is inversely proportional to the resistor. Okay, so now we see that if the resistor increases, what happens to the current? The current decreases. And they are asking, so we have the total current. We removed one resistor. So what happened to the resistor? The resistor decreases. What's going on? If the current increase, the resistor decrease. If the resistor increase, the current decrease. So what happened here? What happened? We removed a resistor, right? So if we removed a resistor, this tells us that the resistor decreased. Okay, I'm just going to take it like this. If I remove a parallel resistor, if I remove a parallel branch, I'm increasing the total resistor. Okay? Yeah. So the total current decrease. So the answer is going to be decrease. Okay, let's try this again. We are removing what? A branch. And if we remove a branch, remember these branches are connected in parallel. The moment you remove one resistor, you are increasing the total resistance. So the resistor is increasing, so the total current decrease according to this formula is directly proportional. It's inversely proportional. If one increase, the other one decrease. So we removed one branch, meaning that we are increasing the total resistor. This decreases the current on A2. So A2 is going to read a less current. I hope that makes sense. I hope everyone is happy about that. How will the brightness of the bulb be affected? By opening as to how is the brightness of the battery be affected. So this has to do with what? To do with power, because now we are talking about brightness. So the brightness depends on power. So let's write that down. So the brightness depends on power. So P is equals to VI. So if P is equal to VI, so what happened to the total current? We said the current decreases. From the previous question, we said the current decrease. So if the current decrease, what happens to the brightness? So what will happen to the power? So this tells us that the internal resistor effect, the battery has the internal resistor of what? The battery has the internal resistor of 0.3, if you still remember that. So when the current decreases, we're going to have what we call V lost. So the voltage lost inside the battery will decrease. So the terminal voltage do what? The terminal voltage will increase. Let me just try to explain this properly, because I know that someone out there really needs these 2 marks. So we said the current will decrease, and if the current decrease, now we need to talk about the internal resistance effect. So we send the battery as the internal resistor of 0.3. So when the current decreases, we're going to have the V loss that is equals to the current times small r. And look at this, the voltage inside the battery will decrease because the V loss is directly proportional to what? To the current. If the current decrease, this decrease what? The V loss. The current decrease, these two guys will also decrease. So the terminal voltage will do what? The terminal voltage will increase. I hope guys you understand. So now what will happen to the bulb? The bulb is in parallel with the supply. This bulb is in parallel with the supply. So the higher the voltage across the bulb. And this tells you that the higher the voltage, the higher the current, means that the bulb will have more power. So the bulb will increase in power. That's how you answer this one. I'm very sorry if you don't understand this one, because I see that I'm also tired on my side, and I think this is the best that I can. This is the best that I can do. Yeah, I think this is the best I can do. Right. So what I'm going to do now, okay, so let's see what we have on the next question. Question 9. The diagram below represents a simplified version of an AC generator, and okay, so the induced current flows from X to Y. We can see that in the coil, when the coil is rotated clockwise as shown in the diagram. Okay, that's what we see there. And then now the question says, the first question, what is the polarity of A? Choose from north or south. I know someone is going to do guesswork. Please sit in the lesson and you'll be able to understand this. Unfortunately, this has to do with the right hand rule. I'm not sure how we can apply the right hand rule while I don't have a camera on, so that I can show you guys this beautiful hand. The beautiful hand that is holding the pen that we are using to make magic kayonane. So unfortunately, the recording that I'm using, I don't know how to do the settings to have the camera on, but as time goes, I'm 100% sure that we're going to improve. Okay, so maybe I can try and explain this one. Since I'm the best, hopefully when I'm done, you'll understand how to collect these 2 marks. Right? So when we talk about the polarity, first let's use the given information. They said that the coil rotate what? It rotates clockwise. Okay, so it rotates clockwise. I'm just gonna put there. And then another thing that they tell us, that the current flows from X to Y. Okay, let's say X2 using an arrow. X to Y. That's how the current flows. So now let's apply the right hand rule for the generator rule. The right hand rule for the generator rule. I hope you guys are taking notes. Have your, okay, the hand right rule is going to be, remember the thumb. The thumb. This guy here is going to tell you the motion of the conduct. This will be the motion of the conduct. right? And then your first finger, the one that, your first finger, so your first finger, this guy will tell you the magnetic field, the direction of the magnetic field, right? So now it's going to be the magnetic field. So now what I need you to understand is that the magnetic field always moves from north to south, né? And then this is one, this is two. The last one about the handwriting rule is that the second finger will tell us about the induced what? The induced current. I'm very sorry that you are writing on top of our diagram, but I'll make sure that when we do, you understand everything. Right? So now let's talk about, once you understand these 3 points, let us discuss the direction of the magnetic field. So for the direction of the magnetic field, we need the field direction that makes current to go from that X to Y. Are you listening? We need, for the magnetic direction field, we need the field direction that makes the current go from X to Y. So for this to happen, magnetic field must go from right to left, because for this to happen, the magnetic must go from left to right. Okay, so I'm going to say why. Now look at this. The right magnet, we said for this to move from X to Y, the right magnet, the one that is on right, will be my north. So this is my north. Let's quickly highlight that. So north, don't worry guys, I'll try to explain this again. This will be my north, and then this will be my south. So now, how did we get the north to be the other one on the left, on the right, and why it's a south? Because we said that we are saying we need the field direction to make a current go from X to Y. You'll understand when we apply the handwriting rule. So for this to happen, we need the magnetic field to go from right to left. And remember here I said my magnetic field always moves from north to south. So if we need it to move from right to left, it's going to be from this point, and then it points in that direction, because it always moves from north to south. So the north one should be on the right hand side, because we need the magnetic field to move from right to the left. I hope you guys understand it. So now the question said, what is the polarity of A? So the polarity of A, the answer is south. So the correct answer here is south. Oh, Jesus Christ. Are you guys with me on that? Do you guys understand? I don't know if there's another way to explain this, but you see, when I just feel like there will be that one learner that needs more explanation, and if I think about this, I'm not sure the best way to put this. I'm not sure to put this. Let's try this again. Let's try this again. So first thing first, we said we need the direction that makes the current go from X to Y. And then now, if we need the one that goes from X to Y, let's look at the thumb. We said the thumb is the motion of the conduct, and then the first finger is the magnetic direction. So now, when this is the magnetic direction, the second finger is the induced current. Right, so when we use the handwrite rule, just know that what is this? Your thumb, it will give us the motion of the conduct. So your thumb will be pointing out of the page. So this is your thumb. We are trying to use the handwrite rule, and then if I use the handwrite rule, let's try it. Maybe someone is going to get it if we use the thumb. So on my thumb, the thumb tells us that this guy here we said is the what? Is the motion of the conduct. So it's pointing out because this has to go clockwise. Okay, so you're going to have your handwrite rule, and then you'll have your thumb pointing out of the page. Okay, so instead of out of the page, let's say you are watching this lesson, you're going to have your thumb pointing where? Your thumb pointing towards away from your screen. Okay, so when it points away from your screen, should it point away or it should point towards your screen? Wait, let's just not leave the pointing away, but let's use this. So this thumb tells us that the magnetic field, remember, it's from north to south. So can you see that the thumb is pointing where? It should be north to south, and we need what? We need to make the magnetic, we need to make the direction to go from X to Y. We need to make the current go from X to Y. And the second finger is the one that tells us the direction of what? Is the one that tells us the direction of the current. Guys, I don't know how to do this while I don't have my current. This one, just take my first explanation, then if you don't understand this, I don't know, maybe I can just do a short video that I can upload after this one. Hopefully you guys can understand how we got south. I'm very sorry. So state one way in which the induced EMF of this generator can be increased. So just know that to increase the induced, there's only one way to increase the induced EMF. There's only one way. From the generator theory, remember that the EMF we say is directly proportional to what? The rate of change of what? The rate of change of magnetic flux. If you still remember, what is this? Grade 11 magnetic flux. So since it's like this, remember, no, there's not that there are many ways that we can do that. We can rotate the coil faster. This one is the best one. We can rotate. State one way in which the induced EMF of this generator can be increased. Number one, we can rotate the coil faster. Right. So another way we can increase the magnetic field strength, or we can increase the number of turns. I know someone is going to take that one, the number of turns. Right. The number of turns. Or we can increase the area of the coil. Just give them any answer that you think it will be best. So sketch the graph of the induced current versus time for one complete rotation of the coil from the horizontal position as shown in the diagram below. Okay, so we're going to plot what we call the graph of current versus time. So to plot the graph, let's check what type of a generator is this. Is this a DC or an AC? Oh, it's even easy. It's given AC generator. So since it's AC, just note that the AC generator, they produce a sine wave. So when I say a sine wave, remember the sine. How is the sine graph? How is the sine graph? So just remember the sine graph now, a sine wave. This will make sense when we draw the graph. For now, just remember that it produces the sine wave. Okay, so let's discuss the important details now. Are we going to have enough space for another question? The important details. Hi, Wenaman. Guys, I'm tired. I think we're just gonna end the lesson now at because this is too much. Then this is the best I can do, guys. Maybe I can make another lesson to complete the question paper, but let's check how many questions left. There's only one left. Come on, come on. We're just gonna stop after drawing the graph, or we can also continue and do 1.9.2. So now, the current versus time produce sine wave. The important details that you need to understand when we talk about the AC generator. First thing first, number one, just know that it starts from what? It starts from 0 at start. Okay, it's going to start from 0 at start, and also that will depend, don't worry, start from horizontal position. That's one. Number two, then the current start from 0. Number three, what we know is that then increase to max, and then it's going to come back to 0. That's how it moves. It comes back to 0, 5, then negative. Then it comes to be negative. I'll explain every step. You can even see the writing that no, this guy is not doing good. Né? Then back to 0. Okay, let's draw the graph now. Let's draw the graph. So my graph will look like this. We know that we're going to say the shape this side is the induced current. Né? So this will be my induced current. Right. So we're saying that if this is the induced, this will be the time. It starts from horizontal. Right. So if it starts from horizontal, it starts here. Then it starts being like horizontal a little. And then the current starts from 0. So this is my current. It starts from 0 because we know that this is 0, so it's going to start at 0. The current starts at 0, and then it's going to, let's do it like this, because let's use the steps that I gave you guys. Let's use the steps that I gave you. I'm going to say it starts let's put it this side using the steps. It starts from 0, it starts being horizontal, then that's 1. Then number 2, the current starts from 0, already indicated that. Number 3, then increase to max. So it increased to max. it creates max there, and then back to 0, and then again negative. Yeah, and then that's it. I'm sorry, this is the graph you can give them next. So now an AC generator produces a max output. They say it produces what? A max output. So the max output, I know that they are talking about the maximum output voltage. This is my VRMS. So the VRMS is given as 340. So this is 340 volts. And then 1120 watt electric kettle operates optimally when it connected to this generator. So this guy here, it's my average power. And the P average is given as 1200. The first question says define the root square. The term root square means find that on your answer sheet, guys. Hey, it's been long. Find that on your exam guideline 9.2.2. On 9.2.2, they want us to calculate the root mean square current passing through the kettle. So we are not even far to formula sheet. I'm just gonna scroll down. The question says find the root square mean. So what they are looking for is the root square mean, which is they are looking for. What was the question? Haibo, guys. Calculate the root square current. The root square current passing through the kettle, the root square current. So we are looking for IRMS. So we need to use the formula that has current. So we are looking for what? The current. So, but when we choose the formula, we need to choose the formula that has power. And the only one that I can use is this one. Which one can we use? This one, because VRMS is given, the P is given. Now we can find the current. I hope this makes sense. Né? I hope this makes sense. Or this one, in fact, we made a mistake. That's not VRMS. Né? I think you guys can see the reason why we need to end the lesson now, because now we are losing interest and we start making those multiple mistakes. Né? So I'm just gonna, this is not my VRS, I was mistaken. This is my Vmax, not VRMX. This is my maximum voltage. I know that someone out there really saw that. So this is my Vmax. It's equal to 340 volts. So to use the formula that says P average is equals to VRMS multiplied by the current RMS. I think you understand where is this formula coming from. First thing first, let's calculate the VRMS. So to find that, I can say VRMS is equals to, the formula is there, Vmax over the root 2. Is there on your formula sheet? The formula is there on your formula sheet. So where is it? VRMS is equal to Vmax all over root 2. So let's quickly put that there and calculate this so that we can end the lesson. So this is Vmax divided by the root 2. So VRMS will be equal to, Vmax was given as 340. So this will be 340 divided by the root 2. So I need you to take a moment, punch that on the calculator. Let me remove this here. Okay, so when I put this on the calculator, I get my VRMS to be 340 over the root 2, and this is 240.42 volts. So I have this, I can substitute it back on this original equation to find my the root mean square current. So let's quickly do that. Let's work on that. So this will be P average, it's equal to VRMS times the current. Let's do the substitution. This is the P average was given as 1.2, if you still remember. So this will be 1200. It's equal to VRMS is the one that we calculated as 240. Multiply this by RMS. Divide both sides by 240. Divide both sides by 240. Then whatever that you get, it's your RMS. So when I punch this on the calculator, I get 1200 divided by 240.42. So this gives me 4.99 amperes. And that's it. The last question says calculate the resistance of the kettle. The resistance. So I'm not gonna waste time on this one. Let me quickly check my formulas. Maybe something will come out from those formulas. They want us to find the resistance, and I'm just gonna go through these formulas and check what I can do from them. I think I'm gonna go with Ohm's law. I'm gonna go with Ohm's law. Because I have the VRMS and I have the IRMS. I don't see any Ohm's law formula in this one. So let's go back up. What is Ohm's law? Ohm's law is this one. I'm going to go with Ohm's law, but remember we are talking about the VRMS. We're going to use the VRMS, and the current is going to be the RMS. So we can use Ohm's law and do our substitution, collect that 3 marks. Né? So I know that someone is feeling for me and say, you know what, say, I rest. Say, I can hear that now you are tired. Say, yes, I'm going to rest now. So R is equals to VRMS over IRMS. So VRMS, we just calculated that to be 240.42. This is what we calculated. So this will be 240.42 divided by our IRMS. So when we divided this, this is the one that we calculated, which is 4.99. Let's substitute that, 4.99. So when you punch this, we should get R. So if I put this on the calculator, I get my R to be 48.18 ohms. 48.18 ohms. And that's the final answer. Guys, I'm very sorry. This is the best that I can do. Hopefully I'll do another lesson, just 10-15 minutes answering the last question. So for this lesson, this is where we're going to stop. Thank you very much, guys, for sitting in on the lesson from question 1. So if this is the first time you are watching our lesson, please make sure that you subscribe, and will make sure that you feel at home. Join the family so that you can get the notification when we upload our next lesson. Our next lesson will be on a past paper, which is Mathematics Paper 2 sub-exam. And hopefully after that one, we're going to work on Physical Science Paper 2, which is Chemistry. Thank you very much, guys, for sitting in, and that's it for this lesson.